Hello everyone, my name is Emmy Maudlin and today I will be presenting my midterm quantitative analysis. First, I did a t-test analysis. My null hypothesis was there is no statistically significant difference between the weight of defensive ends in the 2003 NFL Combine and the 2013 NFL Combine. My skewness and kurtosis values indicated that the data was normally distributed. That means that my skewness values were between 1 and -1, and my kurtosis values were between 3 and -3. To determine which type of t-test to do, I did an f-test, and because my f-stat was less than my f-crit, that indicated that a t-test assuming equal variance was the most appropriate test for this data. During that test, the t-stat was less than the t-crit, and my p-value was 0.23, which is greater than the alpha level of 0.05, indicating no statistically significant difference between the two groups. Because of that, we can accept the null hypothesis. My Cohen d value was 0.36, which indicates that the effect size is small. Next, in the correlation analysis, my null hypothesis was there is no statistically significant relationship between the height and weight of the 2003 NFL Combine athletes. Again, the data is normally distributed. The correlation between the height and weight of these athletes was 0.69. So using the Pearson's R table and comparing that to the degrees of freedom, I found that at the 0.01 significance level, the data is statistically significant. And that is because our R value of 0.69 is greater than the value from the table, which was 0.254. Because of this, we can reject the null hypothesis. The R squared value was 0.47. This indicates that 47% of athletes' height can be explained by weight and vice versa. And the effect size was large because the R value of 0.69 was greater than 0.5. This graph displays what I just talked about. So on the x-axis, we see the height in inches, and on the y-axis, we can see the weight in pounds. We see the trend line is a positive linear relationship, and again, the R squared value was 0.47. For the regression analysis, my hypothesis was that weight, broad jump, and 3-cone drill time can be used to predict a 40-yard dash time. And I used the data pulled from all athletes in the 2003 NFL Combine. The data was normally distributed for each variable, and because the p-value was less than 0.15 for weight, broad jump, and 3-cone drill time, that determined that all of these factors can predict the 40-yard dash time. And I found that the weight, broad jump, and 3-cone drill time can predict the 40-yard dash time with 85% accuracy. This graph displays the regression analysis. It shows to the left the equation that I used to find the predicted values, and on the x-axis is the actual value, and on the y-axis is the predicted value. Again, the R squared value was 0.85. Lastly, the ANOVA analysis, I used the null hypothesis that there is no statistical difference between the weight of the defensive ends in 2015, 2010, and 2000 NFL Combines. My skewness and kurtosis values indicated normally distributed data, and I used a one-way ANOVA analysis. The results of the ANOVA analysis indicated there was no statistically significant difference between groups. The p-value was 0.43, which was greater than 0.05, and our f-stat value was less than the f-crit value. I used a Bonferroni post hoc test, and found a p-value of 0.0167. I did a f-test for each of the comparisons, those being the 2015 compared to 2010, 2015 compared to 2000, and 2010 compared to 2000. All of these had f-stats that were less than the f-crit, indicating an equal variance t-test, and all p-values from the t-test were greater than the Bonferroni post hoc test of p-value of 0.0167, indicating no statistically significant differences between the groups. The effect size of each comparison listed above was small. So in conclusion, the t-test gave us the information that is necessary to understand that defensive ends in 2003 weighed just as much as defensive ends in 2013. The correlation analysis indicates that the taller you are, the more you weigh, and vice versa, and this analysis had a large effect size. For the regression analysis, we found that weight, broad jump, and 3-cone drill time influenced the 40-yard dash time, and that we can predict the 40-yard dash time using weight, broad jump, and 3-cone drill time with 85% accuracy. Lastly, in my one-way ANOVA analysis, there was no statistically significant differences between the weight of defensive ends at 3 time points, 2015, 2010, and 2000. And each of these comparisons had a small effect size. I really appreciate you giving me your attention, and I look forward to your feedback. If you have any questions, please let me know, and I look forward to seeing all of your presentations. Thank you so much.